Welcome. We will continue our discussion on arrays. This is where we stopped in the last video. How do we read the elements of an array? Well, just by reading it element by element, and we can read the elements of an array by the scanf function, and the syntax is familiar to you. Just treat aj as a usual variable. There is a word of caution here. In C, while accessing array elements, array bounds are not checked. For example, suppose you define an integer array, int marks 5. So marks is an integer array of size 5. And then let us say you assign by this assignment statement that you see on the screen, marks, then within square bracket 8 equals 75 semicolon. So here the value of the index is 8, which is more than the size of the array. Now the above assignment will not necessarily cause an error. Your program will compile and run fine. It's quite possible. But it may result in unpredictable program faults, program results. Yeah. So it's the onus is upon the programmer to make sure that the index always takes values which are less than the size of the array. If the index takes a value which is equal to or more than the size of the array, then it may lead to unpredictable behavior, undesirable behaviors. Here is an example of reading into array and doing some computation on it. Okay, so let's go through this program. The first line inside the main is a declaration of a variable, integer variable max size. It's an integer variable with the qualifier const. It stands for constant, and it says that this variable cannot be changed later in the program. It's a declaration cum initialization statement, the first one here, where max size, the name of the variable max underscore size, is declared and initialized to 100, and the constant and the const qualifier says that this variable, the value of this variable cannot be changed later in the program. Although there is a saying that change is the only constant in life, the wisdom does not seem to apply to these variables. Okay, moving on. You define two integer variables I and size, and a floating point array named marks of size, max size, whose value is fixed to 100 all throughout. Yeah, and total is a floating point variable. Then there is a scanf statement where you take an integer as input through the keyboard and store it in the integer variable size. So basically, this scanf statement asks the user for the number of numbers that the user will enter, and that number is stored in the integer variable size. Then there is this for loop, and let's try and understand what this loop does. So if I look inside this parenthesis right after the keyword for, it has three components. We know that this has three parts and separated by semicolons. The first one is initialization. It initializes the variables I and total to 0, both of them. The third one is the update that happens at the end of each iteration. This is I++, which means that the variable I is incremented by 1 after each operation. And the second field is the condition that is checked for at the end of each iteration, which is I less than size. So in each iteration, I is incremented by 1, and you have as many iterations as the value of this integer size. Okay. And now what happens in each iteration? Well, you take in an input through the keyboard. The user enters a floating point number through the keyboard, and that is stored in the next location of the marks array. So in the first iteration, I is 0. So you store the first number that the user enters in marks 0. You store the second number in the next iteration in marks 1, and so on. And then in each iteration, you store marks I, and then you add marks I, which is the number that has just been entered through the keyboard, to the variable total. To the existing value of total, you add the value of marks I and store the result back into total. So total is initialized to 0 here. Yeah. So what happens at the end of this loop? Well, you exit the loop when I becomes equal to size. Yeah. And then the floating point variable total holds the sum of all the numbers that the user has entered. Like after the first number that the user enters is the size of the array. After that, the user enters the numbers that go into the marks array, and the sum of those numbers that are stored in the marks array is currently stored in total after the execution of this for loop. Yeah. Then this printf, what does it do? It prints capital TOTL, capital TOTL, total equal to this percentage f is replaced by the second argument, which is the value of the variable total, which is the sum of all the numbers. Then in a new line, it prints AVG is equal to, and this percentage f is replaced by the next argument, which is total by size. So total is a floating point variable and size is an integer variable. So this ratio is a floating point number, and that gets printed. And as you can see, it's the average entry of this marks array. So this printf prints the total marks and the average marks. And then the main returns and the program terminates. This is a sample output, input output basically. So the user first enters 4, saying that the user is going to enter 4 numbers after this. And then these are the 4 numbers that the user enters. Yeah. And then this is the output. The total is the sum of these 4 numbers, as you can check. And the average is this number divided by 4. How do you print the elements of an array? Again, one element each time, like this for loop. So here, let's say A is a floating point array of size 25. So in this for loop, you print the elements of A, each element in a new line. Yeah, because there is this new line character in the beginning of the string, that the first argument of printf. Yeah. So first you print A0 in a new line, and then you print A1 in a new line, and so on. And alternatively, you can do the following. You can print all of them in one line, starting in a new line. So first you print a new line, and then in a single line, you print all the characters separated by spaces. So you enter a space. So in the first iteration, you print space followed by the value of A0. Then in the second iteration, you print space followed by the value of A1, and so on. How do you copy the elements of one array to another? Again, element by element. So if the array has, let's say each array has size 25, and the arrays are A and B, then you can run a for loop. In each iteration, you copy the element in the jth location, like in the location corresponding to the index j of array B, into the location corresponding to index j of array A. So in the first iteration, B0 is assigned to A0, the value of B0 is assigned to A0. In the second iteration, the value of B1 is assigned to A1, and so on. So note that you cannot assign one array to another directly by an equality statement. Yeah? This is not allowed. Yeah. We'll warn you again of this in a later slide. The element assignments will follow the rules of assignment expressions. We said it before that these array elements are treated as usual variables and can be used in expressions the way ordinary variables can be used. And again, destination array must have sufficient size. The onus is on the programmer to ensure that the value of the index is always less than the size of the array. Otherwise, your program may exhibit unpredictable behavior. You will not want that. Okay. Here is a program that finds the minimum of a set of 10 numbers. So we saw similar programs and programs in the similar spirit in our earlier lecture videos. So this program does not need array really, but here is a program that uses array and finds the minimum of a set of 10 numbers. So first, 10 numbers are taken in through keyboard and stored in an array, and then you find the minimum of the 10 numbers stored in the array. So let's go through this code. You declare an integer array A of size 10 and then these integer variables I and min. Then there is a for loop that reads integers from the keyboard and stores them in array A. So the first integer goes into A0, the second integer goes into A1 and so on. Then you initialize this min variable to the first element of the array, that is A0. Now you go over the remaining elements of the array. So in this initialization part, I is initialized to 1, so the index being 1 corresponds to the second element of the array because the index starts from 0 for arrays. So you go over the remaining elements of the array one by one, starting from the second element, that is the element corresponding to index 1. Now, when you enter a particular iteration of this for loop, the variable min contains the minimum value, the minimum number amongst the numbers that you have seen so far. So initially, before you entered just right after this assignment statement, min holds only A0. After the first iteration, min will hold the minimum of A0 and A1. After the second iteration, min will hold the minimum of A0 and A1 and A2 and so on. So let's see how that is done. So in each iteration, recall, min holds the minimum of A0, A1 through AI minus 1. And now after this iteration, you want min to hold the minimum of A0, A1 up to AI. So what will you do? You will compare AI with the current content of min. And if AI is strictly less than min, that means that AI is less than A0, A1 through AI minus 1. So in that case, you will update min to AI so that after this iteration, min holds the minimum element amongst A0, A1 up to AI. So after this loop runs completely, min will hold the minimum element of the array, which this printf statement prints onto the screen. Okay. So here, note one thing, this array is written only when there are 10 numbers. This array, the size of the array is 10, and this array is declared. In the declaration itself, you plug in the size of the array as 10. So this program can handle 10 numbers. So let's say I want to bring in a little bit of flexibility in the program. This program also can handle 10 numbers, but it's much easier to change this program so that it handles a different number of numbers. Yeah. So in the very beginning, we define a global constant integer variable size, and we initialize 10 to it. Yeah. And then this is the code from the last slide. It's just that instead of declaring A to be an array of size 10, we declare A to be an array of size. So the second size is the name of this variable size, and its value is 10, and it's a constant integer, so its value cannot be changed. Now if I want to alter this code so that it can handle 20 integers, the only change that I make is that I replace this 10 by 20, and there is no other, I don't need any other change in the array. So here, for instance, there is another occurrence of size. So there are many occurrences of size. Wherever 10 appeared in the last slide, we have written size here. So if we want to modify this code so that it handles 20 integers, I'll have to change 10 to 20 in many places. Here. Yeah. And when you have a long program, that may not be very easy. And if you don't do it right, you may mess up something. So it's much safer in this version where there is only one place where you need to change. And then that change is implemented everywhere in the program through this constant variable size. Okay, so we'll see one more way of doing this where we'll use a macro. So let's quickly revise. So macros have been covered in earlier lectures, but let's quickly go over the basic syntax. So hash define x, y. It's a preprocessor directive. So this macro definition, this is a macro definition, hash define followed by a symbolic name x followed by some string y. What the compiler does if it encounters such a definition is that it replaces every occurrence of x in the program with y. This is what it first does. Yeah, this is the pre-processing step, and then the program is compiled. Okay, so let's come back to these points after we have seen an application of this. So this is the same program, slightly rewritten by using a macro. So now we do not use a variable, we use a macro called size. Size was a variable in the last program and also the last to last program. No, there was no size in the last to last program, only the last program. So size is a variable. Now size is a macro, and the macro definition says hash define size 10, and then there are quite a few occurrences of size. So this program is the same as what we had in the last version. So then in the pre-processing step, what will happen is that all these occurrences of size will be replaced by 10. So again, if you want to slightly modify the program so that it can handle a different number of numbers, this macro definition is the only place that you need to, modify. So you just replace 10 by some other number, and you do not have to touch the rest of the program. So let's come back to this. So it's similar effect as read-only variables, but no storage is allocated. So as I said, here this replacement will done in the beginning and then the compilation will proceed. So no space is allocated for x. On the other hand, if I define it as a variable, then certain space is allocated in memory, which will be used to store y. So you save space if you use macro, but we prefer that you use const instead of hash define, because variables also have some advantages. One of the advantages is that a variable is it's typed, so it has a data type. So in this case, it's integer. Now, if in the program you happen to assign the variable some value which is not an integer, then your compiler will throw an error and you will know that something has gone wrong and you can go and correct it. Here there will be no error, so if you do something like that by mistake, there will be no error. Okay, so this is another version. Here you just use a large enough array. So of course, let's say we do not know a priori how many numbers the user will want to enter, but we know that the user will not enter more than 100 numbers. So we can just work with an array of size 100. And then you proceed as usual. Now the user in a particular run can enter much fewer than 100 numbers. In that case, most of the array will not be used. It will be unused. But still you have the same program and you will not need any modification. If the number of numbers becomes 20 from 10 or becomes 50 from 10, you will not need, you were needing to modify one line of the previous two versions, but this program will not need any modification. It will just run as long as the number of numbers is not more than 100. But one downside is that there is a possibility that a fraction of this array is not utilized in a particular run. Okay, so that's all for this video, and we'll continue in the next video. Thank you.